video, we are going to explain about a project titled Diabetic Retinopathy Image Synthesis with Generative Adversarial Network. So now coming to the introduction part, Diabetic Retinopathy Image Synthesis with Generative Adversarial Network presents a transformative advancement in diabetic retinopathy research, providing a powerful tool to generate diverse and realistic retinal images. By overcoming data limitations, this approach paves the way for more accurate and data-driven medical image analysis, ultimately contributing to early detection, improved management, and better patient outcomes for individuals affected by diabetic retinopathy. The generator aims to synthesize realistic retinal image simulating different stages of diabetic retinopathy, while the discriminator's role is to differentiate between the generated image and real images from the limited dataset. So now coming to the objective part for this project, the Diabetic Retinopathy Image Synthesis with Generative Adversarial Network is to leverage the potential of GANs to overcome data limitations in diabetic retinopathy research. By generating realistic and diverse synthetic images, this approach enhances the available data for training deep learning models, leading to improved accuracy and understanding of diabetic retinopathy. The privacy-preserving nature of the method further encourages collaboration and enables advancements in medical image analysis, ultimately contributing to more effective diabetic retinopathy management and better patient care. The generator is tasked with creating synthetic retinal images simulating different stages of diabetic retinopathy, while the discriminator's role is to differentiate between these synthesized images and real images from the limited dataset. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE that is 3.7 version is required. So now coming to the methodology part, first upload fundus dataset. The initial step involves uploading a fundus dataset containing retinal images related to diabetic retinopathy. This dataset should comprise a collection of fundus images from diabetic patients categorized by different stages of retinopathy severity. Second, load GAN model. Once the fundus dataset is uploaded, the next step is to upload the GAN, that is Generative Adversarial Network model. The GAN consists of two neural networks, the generator and the discriminator, engaged in an adversarial learning process. The generator generates synthetic retinal images, while the discriminator attempts to differentiate between these synthesized images and real images from the fundus dataset. Third, load diabetic retinopathy prediction model. In parallel to the GAN, the diabetic retinopathy prediction model is loaded. This model is a deep learning classifier trained to predict the severity of diabetic retinopathy in retinal images. The prediction model should be pre-trained on the fundus dataset, enabling it to accurately classify retinal images into different severity levels of diabetic retinopathy, ranging from normal to advanced stages of the disease. Fourth, generate GAN image and predict severity. With both the GAN model and the diabetic retinopathy prediction model loaded, the system proceeds to generate synthetic retinal images using the GAN. These synthetic images simulate different stages of diabetic retinopathy and effectively augment the original fundus dataset. The synthetic images, along with real retinal images, are passed through the diabetic retinopathy prediction model for evaluation. Fifth, exit. After generating synthetic images, evaluating them with the diabetic retinopathy prediction model, and obtaining severity predictions, the process concludes and the system exits. The results of the severity predictions can be further analyzed and used for research, medical decision making, or assessing the performance of the GAN and diabetic retinopathy prediction models. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as datasets. In this we have some of the folders, and in all these folders they are containing the images over here. Next we have a folder named as image, and in all these we have some images over here. Next we have a folder named as model. In this we have some .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. This GAN model generate, predict, main and train model. These all are the Python files which are containing the Python scripts in it. And here this is the main Python file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload fundus dataset button to load the dataset. Here I am selecting dataset folder and now click on select folder which contains fundus images of 5 categories. And now here we can see dataset loaded. Now click on load GAN model dataset button to load GAN model and generate some synthesis image. So here we can see GAN images, and on this screen text area we can see GAN generated 200 images with size 32x32 and 3 means the images are in color format, not gray. So now closing this, click on load diabetic retinopathy prediction model button to generate and load prediction model to predict severity in GAN images. So here we got a message as to see black console to view model summary, and now we have to click on generate GAN image and predict severity. So now here you can see CNN predicted severity from images generated by GAN model. From 200 images I am displaying over only here 10 images. So we can see moderate class prediction also. So now closing all these images now. Now click on exit button to execute this project, and coming back to the conclusion part. So here in conclusion, Diabetic Retinopathy Image Synthesis with Generative Adversarial Network is a groundbreaking approach that has the potential to transform diabetic retinopathy research in healthcare. Through the synthesis of realistic retinal images, this innovative method exemplifies the power of artificial intelligence and deep learning in overcoming data challenges and driving advancements in medical imaging, ultimately benefiting patients and medical practitioners worldwide. With access to a more extensive and diverse dataset, researchers can develop deep learning models that better understand the complexities of the disease and its progression, leading to more precise and timely diagnosis and ultimately improved patient outcomes.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.